Morning students, welcome. This morning we'll be looking at some word problems, and the first one is as follows. It says the sum of the squares of three consecutive whole numbers is 77. Form a quadratic equation and hence solve to determine the numbers. We don't know what the numbers are, but we know that they are consecutive. In other words, if it's a 1, then the next one will be 2, and the next one will be 3. That's what it means to be consecutive, right? They follow in a sequence. We're going to represent the first number by x. So let us square x then, because it is said these whole numbers are going to be squared, right? So the x will represent the first one in the series. Then the other one, of course, logically would be x plus 1, because we keep adding 1 in the series to determine the next consecutive whole number. We're going to square this as well. And therefore, the other number in the series would be x plus 2 squared. And all of that is supposed to amount to 77. All right? So when we expand on the left, we're still going to have our x squared. When we expand this bracket, we're going to square the x, so we get x squared. 1 times x is x multiplied by 2 is 2x. So the middle term becomes 2x for this expansion, and 1 by itself is 1. The next bracket now is going to be x squared again. 2 times x is 2x multiplied by 2. That's 4x for the middle term. And the end term becomes 4. 2 times 2 is equal to 4. And that is still equal to 77. Alright? So we're going to simplify what's on the left now. So probably have 3x squared. Alright, so we're going to refer to this as 3x squared. We have a 2x and we have a 4x, and that becomes 6x. Right? We have a 1 and we have a 4, and that becomes 5. And that's equal to 77. At this stage now we want to carry over the 77 to the left. So we're going to subtract it from the left, and we also subtract it from the right. So that's going to leave us with 3x squared plus 6x, and this is going to become minus what? 72, because a negative 77 when added to a 5, positive 5, will end up with a negative 72, and over here becomes 0. Wow, so we have an equation in which the leading coefficient is 3. We don't want that kind of a situation. It looks untidy. We want the x squared to be free of any visible number. So we're going to divide everything by 3. So 3x squared by 3. We're going to also divide the 6x by 3. And we'll divide the 72 by 3. And we're also going to divide the 0 by 3. Alright? The 3 cancels that 3, and we're going to be left with x squared. The 3 cancels this 6, and we're left with 2x. And this 3 cancels this 72 to give us 24. So this is 24. So now we have an equation now that is more manageable, right? We can easily factorize this as it is. 0 divided by 3 is still 0. So let's look for two numbers now. That will give us the positive coefficient of 2. When these two numbers are added together, you're going to get 2, right? We bring down one x here and another x here. But we're looking for a number that when you add them together, you're going to get 2. And you're going to get a negative 24 when you multiply them together. All right? It looks as if we're going to have a positive 6 and a negative 4, and that is still going to be equal to 0. If you notice, 6 multiplied by 6 is a positive 6x, and a negative 4 multiplied by this x is going to give you a negative 4x. So when you add a negative 4x and a positive 6x, you're going to end up with a positive 2x. When you multiply this positive 6 by this negative 4, you're going to end up with negative 24. So the two numbers that we needed was a positive 6 and a negative 4. Now what we're going to do next is make both brackets equal to 0. So we're going to have x plus 6 is equal to 0 and x minus 4 is equal to 0. Now what number plus 6 is equal to 0? Negative 6. So that means then that x has to be equal to negative 6. And of course, over here, now x has to be equal to a positive 4, because 4 minus 4 is going to give us 0. So when x is equal to 4, now we're going to go back now to determine the number. We're going to look at the first equation as it was structured here. We know that x is 4, right? X squared becomes 4 squared, which becomes 16. Note carefully now. The next number would have been x plus 1, right? Squared, which is equal to 4 plus 1 squared, which is 5 squared is equal to 25. The other number now is x plus 2, which is equal to 4 plus 2 squared. 4 and 2 is 6. 6 squared is equal to 36. Now let's tally these numbers now and to see if they add up to 72. So 6 and 6 are 12. 12 and 5 are 17. You carry 1. 1, that's 2 and 2, 4 and 3, 7. So indeed, when x equal to 4, it helps us to know to determine the numbers. So the numbers would have been 4, 5, and 6. Therefore, the respective whole numbers are 4, 5, and 6. So this becomes the answer. So these are the numbers that they want. We won't use a negative 6 to determine the numbers, because when you plug the negative 6 into the respective brackets, you're going to end up getting negative numbers, and negative numbers are not whole numbers. So the set of numbers that they're really looking for is 4, 5, and 6. This is a set. You remember that whole numbers are numbers when you add a 0 to the counting numbers. Right? The counting numbers go from 1 all the way up, and when you add a 0 before that, when you add a 0 to the list, it becomes whole numbers, right? Integers now include negative numbers. When you add negative numbers to the whole numbers, then those negative numbers are called integers, right? So we don't want to include the value of 4 when x is equal to minus 6, and so therefore this is the answer. These are the numbers we're looking for. Thanks for watching, and remember, you can subscribe and like the video. Thank you very much.